So we have been discussing about the different bio-inspired related propulsion. So we have discussed about the different actuation behavior which are involved. One of the bio-inspired process is this fibrillar adhesive. So as far as this fibrillar adhesive is concerned, let me just introduce you to this particular concept. So we have discussed about the different types of adhesive in the last lecture. However, this is slightly specific and it has a kind of a it almost gives an impact, and it almost mimic a kind of a lizard or a kind of a spider kind of structure. So ideally, if we observe the mechanism in a lizard or in a spider, so almost such kind of technology exhibits. Okay, so as far as these bio-inspired fibrillar adhesive are synthetic adhesion systems that mimic the micro and nanoscale structure found in the nature, such as gecko feet, insect pad and spider silk. So we have discussed about the in detail about the adhesive mechanism in gecko. However, this particular mechanism is more focused towards insect pads and spider silk. So these adhesives do not require a glue or suction, but rely on van der Waals forces and capillary interaction or electrostatic adhesion, making them reversible, reusable and highly efficient for robotics, biomedical and industrial application. So when we try to look into the overall mechanism of this, so in this mechanisms we have different membranes with nano channels which are being placed. Inside these nano channels we have a kind of a adhesive liquid which is being filled inside. So this adhesive liquid will act as a kind of an interactive medium. So these bio-inspired fibrillar adhesive works based on the physical adhesion principles rather than the chemical bonding. So these mechanisms includes a van der Waals forces, capillary adhesion and the mechanical interlocking. So ideally we have discussed more on these van der Waals forces, which plays a key role with reference to adhesive perspective point of view. The effectiveness of these adhesives depends on the micro and nano structure of fibrils, material properties and surface interactions. Now when we talk about this van der Waals forces, especially with reference to dry adhesion, so these van der Waals forces are weak intermolecular attraction that occurs when molecular dipoles interacts at a very short distance. So in the case of this fibrillar adhesives, it has a kind of a microscopic fiber which increase the contact area with surfaces, which enhances the adhesion. In fact, regarding this, if you remember, we had discussed about a small structure where there are some kind of fibrillar kind of structures are there. Like this is one good example is the gecko feet. We have discussed in detail about it, and some of the key characteristics of it is these are dry and irreversible, so there is no glue required for it, and it has a easy attachment as well as a easy detachment. With reference to directional adhesion perspective point of view, the adhesion is strong and when pulled in one direction and weak when pulled in another direction. Like the gecko peel their feet and it tries to get detached into the structure. Now when we try to talk about the capillary adhesion, which is a kind of a wet adhesion mechanism. So these capillary adhesion relies on the liquid bridges between the fibrillar structure and the surface. So creating an adhesion via surface tension and a capillary force. Example, this tree frog. So if you keenly observe how this tree frog moves, so basically it relies on a kind of a liquid bridge between these structures, which we have seen in the earlier slide also. So these liquid bridge will try to interact with the structure and it will have a hold over the surface so that you can have a kind of an interaction. So now when we try to look into the key characteristics of it, it works in humid and wet condition. Unlike van der Waals adhesives, which fails in wet, these are kind of soft and flexible, so it can adapt to uneven and rough surfaces also. And it's a kind of a pressure sensitive adhesion. It can be tuned by adjusting the liquid viscosity. When we try to look into the interlocking mechanism, instead of relying on molecular forces, interlocking adhesive physically grip onto rough surface using a fibrillar microstructure. So some of the examples of such kind of interlocking mechanisms are beetles and spiders. Some of the key characteristics which are involved in it are, so it has a high strength adhesion. So ideally it is used for heavy and load applications. As far as roughness perspective point of view, it works on rough surfaces, unlike van der Waals forces or capillary adhesives. Durable and wear resistance perspective point of view, it is designed for a kind of a long-term usage. Some of the key design features of this fibrillar adhesives are, it's a kind of a hierarchical fibrillars. So basically it maximizes the surface contact for strong adhesion. It has a kind of a bio-inspired example, like a kind of a gecko state. Directional adhesion, it allows easy detachment and when needed, and gecko food peeling motion. Next, as far as some of the key features includes the self-cleaning ability. So when we try to look into the function of it, it prevents the dust and debris accumulation. So some of the bio-inspired example includes the kind of a gecko setae regeneration. And a water resistant design perspective point of view, it maintains adhesion in humid environment, like how a tree frog or the insect bag works. So similar to this, it maintains an adhesion. It has a soft and a flexible material. It enhances the capability to a curved surface. So this is one of the key advantage where we could observe with reference to this tree frog footpads. Now let us discuss some of the factors which are affecting these adhesion performance. So one of the factors basically includes the surface roughness, where a van der Waals adhesive work best on smooth surfaces and interlocking adhesives perform better on rough surface. Environmental condition perspective point of view, it has a humidity. The capillary adhesive performs better in humid environment. And as far as dust and contamination is concerned, these van der Waals adhesives may lose efficacies as or when based on the different environmental condition. With reference to material property perspective point of view, these are kind of soft, elastic materials and it improves the adaptability, and it has a nanostructured material with increased surface contact area. So these are some of the key properties which comes into picture with reference to adhesion performance perspective point of view. Now let us see some of the applications of these bio-inspired fibrillar adhesive structures. So one important application is the climbing robot. So as far as these if we are designing a kind of a gecko based robot, this robot uses a gecko inspired footpads for wall climbing. So there are several examples. In fact, there is a NASA based gecko. NASA has developed a NASA gecko gripper robot which is used for some kind of space related applications. Then with reference to biomedical device perspective point of view, when we try to talk about the working, these soft adhesive replaces the harmful glues in surgical patches and bandages. Some of the examples include a gecko inspired wound dressing. And with reference to space application perspective point of view, these fibrillar adhesives help astronauts to grip object in zero gravity. So this is one good application where a NASA dry based adhesive technologies are being deployed. Then in manufacturing and assembly perspective point of view, it maintains adhesion in humid environment, and some of the good examples include robotic arm for microchip handling is one good example where such kind of adhesion based structures can be deployed. Wearable sensor and prosthetic perspective point of view, these enhances adaptability to curved surfaces, and with reference to example, it is used in smart bandages and biosensors. Some of the key challenges which is observed in this fibrillar adhesive is a loss of adhesive over time, like use of self-healing materials to restore the fibrillar structures, scaling to a larger load, design a multi-layer fibrillar array to contribute weight efficiently, dust and contamination buildup. So develop a self-cleaning fibrillar like gecko feet is one of the solutions which are being established. Now with this as a fundamental, now let us discuss about a lizard inspired water runner robot. So as far as these lizard inspired water runner robots are concerned, so this is one good example, like this is a kind of a chameleon based lizard. So if you closely observe in this, so we may need to mimic three different portions of these water runner robot. So one portion is the head portion, the other portion is the abdominal portion, third portion is the kind of the portion which is used for pushing it forward. So like the overall buoyancy, the overall equilibrium is maintained by the head portion as well as by the abdominal portion. So abdominal portion will take care of the overall center of gravity, and then the head portion will have a kind of a movement, so which takes care of the overall direction of the system. So in this particular aspect, if you see, so for this abdominal portion we can have a kind of a servo mechanism, so that this servo mechanism will be helpful for a continuous like a locomotion in the system. So similarly, so here we can have a kind of a direction mechanism. So this direction mechanism will take care of the overall movement of the structure, and this structure more talks about the overall load capability. So with reference to load capability perspective point of view, either we can have two sets of motors catering the limb structure. So in this limb structure, so we can have one set of motor catering this particular movement and the other set of motor catering this particular movement. So appropriately, so we can have a kind of a theta orientation which exhibits over here. So these theta orientation will give the kind of a load which acts as a kind of a load bearing motors, so that the load can be easily calculated and appropriately we can expect a movement coming out of this structure. Now, as far as these lizard inspired water runner robot is concerned, so this is a kind of a biomimetic robotic system which is designed to replicate the remarkable ability of certain lizards, such as in this particular operation. So we are considering this basilisk lizard. So in fact, this basilisk lizard is used to like it's a kind of a lizard which is being the mechanism of the lizard is well studied, and it is mainly some of the different micro robotic structures has been developed using this. So this basilisk lizard will to run across a water surface at a high speed. It has a capability to run across the water surface at a high speed without sinking. So these robots leverage principles for surface tension, hydrodynamic, a kind of a foot slapping mechanics, and a lightweight structural engineer to achieve a rapid locomotion over the water. So by integrating this bio-inspired limb motion, a hydrophobic material and energy efficient actuators such as robots have a potential application in surveillance. It also has a potential application in search and rescue operation, environmental monitoring, and military related application, especially in the case of this amphibian related areas, etc., basically focusing on the water based terrains. So let us discuss about some of the key principles behind this biological inspiration of this basilisk lizard. So these basilisk lizard has an extraordinary ability to run on water at a speed of close to around 1.5 meter per second for several meters before sinking and switching to a swimming mode. So this is one advantage. Like ideally it's a kind of, it cannot be categorized directly as an amphibian, but it can be used as a kind of a lizard which can walk on the water surface, and it can also go for a swimming mode. So if we closely observe the locomotion of these particular basilisk lizard, so the key principle behind this unique locomotion ideally includes a high-speed limb locomotion. So the lizard hind leg move at 5 to 10 steps per second, creating a sufficient lift and a propulsion to keep it above the water. As far as these foot slapping and lift generation is concerned, the lizard slaps the water surface forcefully, generating an upward thrust by trapping air pocket under its feet. As far as this when we try to look into the hydrophobic capability of this hydrophobic skin and toes, it has a kind of a specialized scaly foot structure and hydrophobic skin which prevents an excessive water drag. And when we try to look into the body weight distribution, by keeping it at the center of mass forward, forward, the lizard maintains a stability while running. So in fact, this is what we had discussed, like when we try to consider it as a 3 different component. So the overall mass or the weight distribution is, which we are considering it as under the abdomen, appropriately we may need to design the mechanisms to take care of the overall equilibrium in these structures. Then transition to swimming. So when speed decreases, it switches to swimming using a kind of a lateral undulation techniques, which is considered to be, which can also be considered as a kind of a biological inspiration. Now let us consider some of the key components of these lizard inspired water runner robot. So we are trying to categorize these structures under 2 different categories. One is towards the structural design, and another one is towards the actuation and the locomotion design. So when we try to look into the structured design, the body material, it's a kind of an ultra lightweight material such as carbon fiber and a titanium alloy, and it has a high strength polymer to minimize weight, and it can be used for maximizing the buoyancy. As far as these coatings are concerned, so it's a kind of a hydrophobic coating, so ideally so that it doesn't stick onto the surface and it doesn't has any impact on the electronic structure. So the robot surfaces and the feet are coated with a super hydrophobic, ideally a kind of a PTFE based graphene or a nano coating to reduce the drag, like it to drag in the leg design. So when we look into the leg design perspective point of view, it's a kind of a long jointed length with flexible feet that replicate the foot slapping motion of the basilisk lizard. So in fact, we had discussed about the slapping motion and the recovery motion. So here, this leg design will try to cater the slapping motion for an efficient movement. Then we can also talk about a webbed foot pad. So these webbed foot pads are mainly meant for increasing the surface area for the maximum lift. Now, when we look into the actuation and locomotion mechanism perspective point of view, to replicate the lizard fast foot slapping motion, the robot uses, there are different types of actuator which are used. Ideally, based on the type of the energy density, appropriately actuators are taken up. So we have the electromagnetic actuators. So these, when we try to look into these electromagnetic actuators are high speed motor which generate a kind of a rapid leg oscillation. Then we have the piezoelectric actuators. As far as these piezoelectric actuators are concerned, it enables a precise and an energy efficient movement. We have the shape memory alloy actuators. So these shape memory alloy actuators are kind of a soft robotic actuator for flexible foot movement. Then we have the bio-inspired joint mechanism. So ideally it has a kind of an adapt and rotational and vertical motions to replicate the natural leg movement. Now when we try to look into the propulsion perspective point of view, propulsion and stability control perspective point of view, these hydrodynamic foot slapping, it creates an air pocket under the feet for lift and forward momentum. So it has a kind of an adjustable gauge cycles. These robot adapts a step frequency and force for different water conditions. When we try to look into the gyroscopic perspective point of view, these gyroscopic sensor ensures the balance by preventing an excessive tilting or sink. Now, when we try to look into the overall power source and the energy management, there are a certain amount of micro batteries, which is a kind of which we call it as a lipo-based batteries. They provide a lightweight and a compact power. When we try to look into the wireless power transfer perspective point of view, these systems enables a continuous operation for surveillance related applications. In addition to this, the system also has a provision to have a kind of a solar energy integration which enhances the autonomy in the field operation. Now, if we closely observe the other kind of systems like sensor and navigation systems, so we may need to look into the different sensors which are deployed for such kind of navigation. So some of the sensor includes the inertial measurement unit MUs, which monitor the acceleration and stability, optical flow sensor which tracks the movement and are relative to water current, LiDAR and ultrasonic sensor which helps in avoid obstacles in water environment, AI based control systems, which are kind of an adaptive learning, which allows the robot to improve the balance dynamically. So this AI based system will be helpful. So when there are two modes of working environment, when the robot is made to work in the two modes of working environment, so appropriate inputs can be attracted and appropriate decisions can be made using these AI based control systems. Now, when we are considering, as I had mentioned earlier, when we are considering running on water environment, so ideally we expect that it should have a high speed limb motion. So ideally the quantified value is in the range of 5 to 10 hertz, which ensures the robot to generate a sufficient amount of lift to avoid the sinking behavior. Then there should be a kind of a precise foot impact, which timing allows a forceful water slapping to support the weight. And then in addition to this, there is a kind of an hydrodynamic lift enhancement, which ensures that the robot can maintain a speed efficiently. When we try to look into the locomotion mechanism, when there is a transition between a running and a swimming, so if the robot loses the speed, it automatically switches to the swimming mode. So ideally what happens is, when it is running in a kind of a land and when it tries to touch a water surface, of course we all are aware about it, there will be a kind of a drag which will be generated, which will try to slow down, and once it senses the speed and once it understands the speed is getting reduces, it tries to switches to a swimming mode. So in this swimming mode, we have a kind of a lateral undulation where there is a kind of a snake like movement which exists. It also has a propeller assisted propulsion. So in this propeller assisted propulsion, so we can engage a kind of a engage a kind of an induction which exhibits which caters the propulsion mechanism. And then there is a kind of webbed foot paddling. So these webbed foot paddling are mainly meant for a kind of a it has a kind of a sensory system which will try to actuate at a frequency so that it will be helpful for the system to move in a forward movement. Now, when we try to look into the steering and the maneuvering mechanisms, so these asymmetrically leg force application enables a sharp turn in the structure. The yaw control via a differential limb motion for a quick directional changes. The front leg for an additional control, like a kind of a rudders in a boat, are ideally used for steering and the maneuvering. Now, with reference to application perspective point of view, it is highly used for military and surveillance applications. Like it is used in a water heavy terrains, like example river crossing, or it can be used for kind of swamp areas, etc. It has a potential application towards stealth movement for security operation in marine environment. And it also has a capability towards autonomous intelligence in gathering in flooded or a difficult to access zone. So these are some of the areas where it can be focused. With reference to environmental monitoring and wildlife search perspective point of view, so it is highly, so some kind of sensors can be integrated in such kind of robot in detecting the pH and salinity and the pollution level. So basically it can be used for a kind of a water quality assessment. It can be used for tracking the aquatic ecosystem. So studying this waterborne species and the ecological changes can be easily studied using the system. And then we have a kind of a wildlife surveillance. So in this wildlife surveillance, we observe a waterbound animal behavior without disturbances. Now, when we try to look into the recreation and the educational robotics perspective point of view, it has a kind of a advanced biomimetic robotic research for universities and research institutions. With reference to education perspective point of view, it has an educational kit to teach the biomechanics and the hydrodynamics and the robotic principles. With reference to entertainment and robotic sport competitions, it is involved in the kind of a water-based robotic challenges as some of the key applications with reference to recreation and educational robotic perspective point of view. Next, with reference to disaster response and search and rescue operation, it is mainly meant for rapid deployment in flood affected areas. It is also used for monitoring the submerged or a semi-submerged zone to detect the surveyors. It is also used for assessing the water pollution and the contamination in the post-disaster environment. So these are some of the disaster response which such kind of robots can be used. Now, let us see some of the challenges which are involved in developing this water runner robot. So one of the key challenge which includes maintaining a speed and stability. So like achieving and sustaining a speed of 1.5 plus meter per second is difficult with excessive energy consumption. So in the expense of energy consumption, appropriately we may need to have a control over the sustaining speed, and it is used for balancing between the water impact force and the stability, which is considered to be a crucial to avoid the tipping over. Next, with reference to energy efficiency perspective point of view, which is considered to be one of the key challenges involved in such kind of water runner robot, that is, rapid movement require a high power input, making the battery life a major challenge. Then one of the important aspect is this alternative solution, which includes a kind of a wireless charging or a energy harvesting mechanism. So this is considered to be one of the potential challenge which can be addressed by this energy efficiency. Now, with reference to controlling locomotion on varying water conduction perspective point of view, adjusting to different water surface, it requires an adaptive AI control. A dynamic leg force modulation is needed for maintaining a speed across a diverse water environment. So transition from water to land. So these kind of basilisk lizards can move seamlessly from water to land. It is used for replicating these features in robot, which requires a hybrid locomotion strategies. These soft robotic joint could enable the robot to adapt leg movement based on the different types of terrain as and when it is required. Okay, so these are some of the challenges which are involved with reference to water runner robot perspective point of view. Now we will discuss about the next concept or the next technology, which is called as a water strider inspired water worker robot. So in the earlier cases, so as far as in this particular mechanism is concerned, what we have observed is these kind of lizards will be in the land and it will try to walk on the water, and it has a capability to swim on the water, and again it goes to the land. So it has a more attraction towards the land than the water. However, if we can design a system where it can float on the water, so such kind of mechanisms can be deployed by a kind of a water strider. As far as these water striders are concerned, these water striders are inspired by water worker robot. So like as far as these water strider, so this is a kind of a water strider, so which will try to float on the water, and it can so it doesn't directly swim, so it can be used for standing on the water surface, and it can be used for movement of the water. So as far as these water strider, it is inspired water worker robot is a kind of a bio-inspired robot system designed to mimic the unique ability of a water strider. Basically it comes under the family of Geridae family insects. It is mainly meant to walk, to jump and maneuver across the water surface without sinking. So ideally it can float on the water, or it can stand on the water and it can float on the water. So by utilizing the principle of surface tension or hydrophobicity and lightweight structural engineering, these robots enable an efficient aquatic locomotion, offering potential application in environmental monitoring, military surveillance, biological studies and disaster response. So these are the applications where such kind of water striders can be effectively employed. So these are the closer view of the water striders. In fact, there is a group which has published about, which has taken up a video on this water striders. You can refer to this YouTube. Now, if we keenly observe the different mechanism which are involved in such kind of water strider or water worker robot perspective point of view, like, so we can categorize these mechanisms as like, in fact we have discussed about this in the earlier module also, about the different like slab phase and a stroke phase. Okay, so like first is a kind of a recovery up and recovery down mechanism. Then we have the stroke phase, we have the slab phase, we have the final push phase, and the loop shaping phase. So let us consider this is a kind of a water strider which is there inside the water. So initially, like if you consider this as your reference, so this is kept on top of the reference, and then there is a kind of a structure where like it is meant for like a kind of a slapping phase, and then we have a kind of a stroke phase which exhibits over here. Now let us discuss about the different phases which exhibits in detail. So as far as in this recovery up and recovery down mechanism is concerned, or in the recovery up and recovery down phase, the recovery up phase, the foot though submerged, is assumed to exit the water through the cavity which was formed during the slapping and stroking phase. Now for this, first we need to have an understanding about the slapping phase and the stroking phase. So as far as these slapping phases are concerned, during the basilisk slip, the slap phase can convey an extra amount of lift depending upon the speed and the contact and the power abilities of the lizard. This phase of the step is for all position where the ankle height is lower than the water height and the velocity angle is less than the negative of 45 degrees. So at this time, the slap phase is covered, like it is hoped that it will yield a conservative estimate on the lift which is provided by the robot, as the slap phase in reality provides a surplus amount of lift phase. Now when we try to consider a stroke phase, the stroke phase begins when the ankle velocity angle is equal or greater than the negative 45 degrees, which when this occurs depends upon the water height and the loop shape, but in general it occurs shortly after the ankle is being submerged over here. So this phase continues until the ankle has reached the lowest point of the loop, and the drag of the loop is assumed to be a kind of a force which is being exerted on it. Now we can create this loop shaping in such a way that we can have a drag phase and a lift phase. Now when we try to talk about the recovery up and the recovery down, so in the recovery up phase, the foot though submerged is assumed to exit the water through the cavity which was formed during the slap and the stroke phase. So the drag on the foot is thus considered as 0. Consecutively, when we try to consider the force along the x and the y plane at 0, so this phase is during this recovery down phase of the step, the foot is above the water level and it is entirely in air. So forces are assumed 0 and the phase lasts of all proportions where the ankle height is greater than the water height. So these are some of the mechanisms which are being deployed with reference to water strider for the movement of the phases. Now let us discuss about the different principles which are involved for this water strider locomotion. So to design an efficient water walking robot, so the researchers have analyzed the biomechanics of the natural water striders. So if we closely observe the different biomechanics which are involved, so one is a kind of a surface tension utilization. So in this case, the water striders rely on a surface tension which prevent them from breaking the water surface, and their leg distributes weight evenly, preventing the submersion. When we try to talk about the hydrophobic leg, the strider's leg have a microscopic wax coated hair structure which we had discussed earlier also, which we called as setae, that repels the water and a trapping air which will enhance the buoyancy. In fact, that is what we had seen in the 4 to 5 slides before, where we could see there is a kind of a column over which we have a kind of an interaction of the liquid along the surface. Then we have a kind of a leg-based propulsion. So in this leg-based propulsion, a water strider move by pushing against the water with their middle leg while using the front leg for steering and the hind leg for the stability. So appropriately an equilibrium is maintained with reference to the steering and the stability, and the equilibrium is established. Next, when we try to talk about the jumping mechanism, they generate sufficient force to jump off the water surface without breaking it, leveraging their lightweight bodies and the specialized joint mechanics. So these are the different principles of water strider with reference to the locomotion. Okay, so let us discuss in detail in the upcoming classes, especially with reference to key components of this water walker robot in detail in the upcoming classes.